Introducing integration. Calculus. There are two types of calculus, differentiation and integration. Differentiation calculates the gradient or slope. Integration finds the area under the curve. There are two types of integration, definite integral and indefinite integral. Integration is the reverse process of differentiation. When we integrate, we start with the derivative, and the derivative is the gradient, the y dx, or the f of x over the x, and then find the function y, which is f of x. The symbols integral f of x dx denote the integral of f of x. So that symbol is integral of f of x with respect to the variable x. The symbol integral was developed from capital S, so it doesn't look like x, more like elongated S, which stands for summation. That means we're adding all the area together to make the collected area, which was used in the 17th century. Integration is the process of finding the area under a curve. If we have a curve y equals f of x, and this curve, we want to find the area between that boundary and this boundary, where here x equals a and x equals b, what we want to do is find the area under the curve. And that area a, which is a function of x here. So the area a of x, because the function is x, will be equal to integral that function y, which is a function of x, times the x. The difference between these two is the x, and equals x to power of n plus 1 over n plus 1 plus c. And this is called the indefinite integral. Indefinite means infinity. So that means you can integrate the whole area of the function to infinity. But we also have definite integral, where a of x for the definite integral will be integral of where x equals a, the lower limit boundary. This is the lower limit boundary, and that's the upper limit boundary, and x equals b, y the x. Why do you have y the x? Because when you're finding an area of a rectangle, for instance, if you have a rectangle, if I have a diagram y, this is y, and this length here is the x. So the area will be y times the x. That's why we have y times the x. But we have little y times the x because they make up the area. So another y times, so if you have tiny little one again, so we have to make them so small, the x, so that the error limit is so small. So that's why we have this summation. We're adding all of them together. That's what this summation means. Summation means addition. So we're adding all of them together. And that's why we got the area, adding all together from the lower boundary to the upper boundary, the lower boundary to the upper boundary. That's what we called the definite integral. And that's what this is. And that is x to the power of n plus 1 over n plus 1 square bracket. Then we say x equals b, the upper boundary, and x equals a, the lower boundary. It just means that it will be equal to, you substitute b for x here, so you're going to get b to power n plus 1 over n plus 1 minus a to power n plus 1 over n plus 1 equal to the area. But c, in this case, we cancel out. because if you have plus c here minus c here, plus c and minus c will be 0. So c will cancel out. As you know here, c is a constant. So this one here is the definite integral. A is the lower limit boundary and b equals upper limit boundary. Yes, the integration and differentiation are reverse process. Differentiation is finding the slope of a curve, and integration is finding the area of a curve. Whenever you differentiate, your function has to be in the form of y equals x to the power of n. Whenever you integrate, your function has to be in the form of y equals x to the power of n as well. So for either differentiation or integration, the function you're differentiating or integrating will be in the same form. Y equals x to the power of n, y equals x to the power of n. If it's not in that form, you have to make it to that form.